This is the tutorial for the answers to the study guide for algebra, study guide number 10. And so let's take a look at our first problem here. And so it asks us to graph the equation. It doesn't specify the method, so we could use any method. And when I look at this equation, it's already in the slope-intercept form. So I'm going to use the y-intercept, which is this term right here. This is my y-intercept, and my slope. And so as long as the equation is in the form y equals mx plus b, I can go ahead and use this form. So again, y is by itself. I got the slope in front of x, the coefficient of x, the y-intercept being added to x. So I'll start two spaces up, put a dot right there, and then use that slope. The slope is 1 to 3, so that means I go up one space, 3 spaces to the right. I can also go the other direction, down 1, 3 spaces to the left, and get on that same exact line and be able to draw a line through there. So taking a look at the next equation, I want to get the y term by itself. So I'm going to add the 2x to both sides, and I'm left with this, y equals 2x plus 4. So now I have my y-intercept and my slope. So now this is my y-intercept, and my slope is the 2. And so I'm going to treat that slope as a fraction of 2 to 1. So I'm going to start 4 spaces up on the y-axis. I use that slope, and again, this time the slope is positive, so you go up to the right just like we did with this one. However, I can't make it up that far, so I'm going to end up going the other direction, which is down and then to the left. So negative 2 over negative 1 gives me the same exact slope, same answer. So it's a line going uphill from left to right. Both x and y values are positive as we go from the left to the right. And so the next one, it says Ed is already 40 miles away from home on his drive back to college. He is driving 65 miles an hour. Write and graph an equation that models the total distance d, traveled after h hours. So that right there tells us what our y-axis is and our x-axis. So the x-axis represents number of hours. And I'm going to go ahead and write down h for that instead of x. And so it's typically good. This is going to be our independent variable, and it's independent in that we can have any number of hours, but the distance depends on the number of hours we drive. So the total distance is going to end up going here. I'm just going to write distance going down. Distance, and I'll write down that we are in miles. Now I know I'm in miles because the rate is in miles per hour right here. So now I got to figure out how to number the intervals and what I should do there. But before we do that, let's go ahead and write the equation. So distance equals, and then we've got the rate, 65 miles per hour, and then plus the extra 40 miles we are already from home. So that's going to end up being our equation. So let's figure out what kind of intervals would work well. So looking at the amount of space I have, I think I'm going to go ahead and go by 20s. So I'm going to put 40 down here, and then 80, and then go with 120, 160, and that should get us far enough. And so over here on the hour side, it's not going to take too many hours to get pretty far because we're driving 65 miles an hour. So I'm just going to go by ones. So I'll skip every other one. So I'll just do the even ones here, 2, 4, 6, and 8. And then we'll go ahead and mark some points to start at with the y-intercept is the ultimate point to start at there. And then going up 65. And so up 1, that's 10. Let's see here. Actually, that's 20. 40, 60, 65 is going to be about a quarter of the way up over 1 hour, and so that's going to be about where we're at. And so that's enough for us. Let's go ahead and draw the line between those points, and we'll extend it past the point that we had there, and arrow at the end signifying that it can go on for some time in that direction, but it does not go past the y-axis or the d-axis, the distance traveled, because we won't have negative time. So that's our equation. Let's take a look at the next problem. So again, they asked us to write and graph. So the graph here with the labels on there is good, and then the equation right here. So taking a look at the next problem, it says to write an equation in slope-intercept form. So that means we're going to write it in the y equals mx plus b form. And they give us that it passes through this point with a slope of 1/3. So we're going to use point slope, so y minus -4 equals, and then we have the slope of 1/3 times by x minus 3. So we just take our point, plug it in for y1 and x1, and then we distribute. So we're left now with a y plus 4, because add the opposite there, and we get a 1/3 x minus 1. 1/3 of 3 is 1. So all I have to do is subtract the 4, and we'll get our answer. Y equals 1/3 x minus 5. Add the two numbers because we have the same sign. So the next problem, very similar, however we have to find the slope first. So remember the slope is y minus y1. So I'm going to do 4 minus 1. So I'm taking this 4 and this 1 right here and subtracting them. Then down below, I'm going to end up doing 1 minus -1. So I took this 1 right here and I subtracted from this -1. So when we go ahead and get our answer, it would be 3/2. I added the opposite here to get +2. So now I use the point slope method. So y minus 4 equals 3/2 times by x minus 1. So I distribute, and I have y minus 4 equals 3/2 x minus 3/2. So I end up having to add 4 to all sides. So when I add 4 to this side, I'm going to change 4 so it has a denominator of 2. And so I'm going to change it to 8/4. I'm sorry, 8/2, that is. Let me fix that. 8/2. 8/2, 8 divided by 2 is 4. And so this way I can see right away I just have to subtract the numerators because they are opposite in sign. So my answer is y equals 3/2 x plus 5/2. And then again, if you wrote 2.5, 2.5, those are all good numbers for 5/2. Take a look at this one. We have to write the equation in slope-intercept form, and then we also have to interpret the slope in the y-intercept. So the first step is to find out what the slope is. So 25 5/10 minus $8.50, and this is all over 3 minus 1. And so when I do that work, we ended up with 17 over 2, which is 8 5/10. I'm going to end up using that number in this case because we have y minus, and I'm going to use the 8.5 equals, and then we have that slope of 8 5/10 times by x minus 1. So we distribute, and we have a y minus 8 5/10 equals 8 5/10 x minus 8 5/10. So whenever you have the same term on both sides, same sign and all, you end up canceling it out. So you'll see here, if I go ahead and add the 8 5/10, it'll cancel it out on both sides. So we're left with this as an answer. Y equals 8 5/10 x. So here we have a y-intercept of 0. So the y-intercept equals 0, which means let's see here, the worker only makes money on his or her wages. So that means there's no starting amount you get paid. We don't start at $40 just for being there. We only make money if we work a number of hours. We get $8.50 an hour, and that's what they're asking in the next question. So the next question is, what does the slope mean? Well, the slope is equal to 8.5. So what does this mean? Well, it means that we make, we'll say, the worker earns $8.50 per hour. And so that's what we end up saying there. So let's take a look at our last three problems. It says find the x and y intercepts, then graph the equation. So for the x-intercept, I'm going to set y equal to 0. And when I do that, I'm left with this, 2x equals 4. So you're kind of canceling out this term. We're left with 2x equals 4, so you divide by 2, you can see how x is 2. So 2 comma 0. That is the x-intercept. So going over 2 spaces on the x-axis, that's the point. For the next one, we have negative y equals 4. I get that by taking out the x term, setting that equal to 0. And we're left with dividing by negative 1 gives us y equals negative 4. So 0, negative 4. So that's the x and the y intercepts. Plot those points. So 1, 2, 3, 4. And draw the line between the points. So looking at the next question, it says write and graph an equation with no slope. So here answers can vary. Answers can vary. However, the line must be vertical for the no slope. So we must have a vertical line. So it looks something like this. If I drew a line right through x at 2, this would be x equals 2. X equals 2. So it says to write and graph an equation. Here's the equation. It's going to be x equals any number. Whatever number it is, you just have to go through that value on the x-axis. So here it says write and graph an equation with 0 slope. So answers again can vary. Answers can vary. But the line must be horizontal. So it's got to be a horizontal line. So it doesn't matter where you draw it. I'm going to decide to draw it right down here. And that would be y equals negative 3. So as long as you have y equals a number, you've got the right equation. It's got to go through the y-axis at that value. So the last problem says a store sells gift cards for $10 or $25. You have $285 on a gift card. On gift cards, write and graph an equation to represent the situation. So we've got to assign some variables. So it doesn't matter which one. There's no independent or dependent variable here. We just have to assign one. So I'm going to say, let's write it down here, x equals the number of, let's go with the $10 gift card. Gift cards. And we'll just say y equals the number of $25 gift cards. So again, it doesn't matter which one we pick there, and your line will vary a little bit depending on which one you pick, because one it'll be a little steeper and the other will be a little less. Depends on, again, which one you value, which one you put in here. But I do want you to label the axes as well. So put down the number of $10 cards, we'll just say. And this is the number of $25 cards. And so now we have to figure out our axes, or what our intervals are. So now I'm going to go ahead and write the equation before I do that. So it's going to be 10x plus 25y. So I got that by doing $10 times the number of $10 gift cards plus 25 times the number of $25 gift cards equals the total amount, $285. So let's find out what our x value is. So our x-intercept, we set y equal to 0, and we divide. So this is a great intercept method because we can't have negative gift cards. You can only have positives, so that's why we're just in this first quadrant. Now notice I don't have an even number of them. I got 28.5, so I can't buy just $10 gift cards. I have to buy some $25 ones. So I'll plot that point in just a moment, but let me get the y-intercept. So I do it the same way. 25y equals 285. And when we divide by 25, it doesn't go in there either. And so I'm left with y equals, this makes 11 and 4/10, 11.4. So I'm going to end up figuring out what units I should end up using now. So looking at 28.5 along the x-axis, I think I'll end up going by 4s to be able to fit that number in there. So 8, 16, this would be 24, and 32. So 28 is right in between. So 28.5 is just a little bit more than that line. And then 11.4, I don't have to go by as steep of a, or as high of numbers. I think I'll go by 2s. So I'll call this one 4, 8, 12, and 16. And 11.4, well, this is 10 right here. So 11 is halfway up. So 12 or 11.4 is going to be pretty close to the 12 line. So I guess it'll be about right here. Just a little under that 12 line. And then we draw the line between those points. And so the actual solutions are anywhere along there, but can't have a part of a gift card, so we'd have to find out where they exactly meet at one of these intervals. So those are the types of problems you're going to see on this week's test. Good luck.